6.1 through 6.5 review. This is the review for the quiz 6.1 through 6.5. I'm going to take some of these over to another page so I have a little more room to work. Make sure when you're doing these, you're actually reading the instructions and you know what I'm asking for. Number 1 through 4, decide if a linear, quadratic, or exponential function best describes the data in each table. Find the function. So the first thing I want to do is do my differences. Always start with differences. 3 minus 0 is 3. 12 minus 3 is 9. 27 minus 12 is 15. 48 minus 27 is 21. My first differences are not the same, so do my second differences. 9 minus 3 is 6. 15 minus 9 is 6. 21 minus 15 is 6. My second differences are the same, so that tells me that this is quadratic. What is my equation? I know it's in the form y equals a, x squared plus b, x plus c. A is half the second difference. So A is half, A is half of 6, or it's 3. C, I always like to do C next. So A is half of my second difference, so A is 3. C is y when x is 0, so C is 0. To find B, I need to do FUD. My first difference is equal to A plus B. My first difference is 3. So 3 is equal to A, which is 3 plus B. Subtract 3 from both sides. 0 is equal to B. So my equation is y is equal to A, which is 3x squared plus 0x plus 0. So y equals 3x squared is my answer. Let's look at number 2. Number 2, if I do my differences, I get 3. I get not 9. 7.5. I'm going to stop there. That's a huge differences. It could be that it's possible that's quadratic, but because of all the fractions, I'm going to go ahead and check first if maybe I need to do successive quotients. Maybe, just maybe, it might be exponential. Since I have all those decimals and I would like to save a little bit of time, I'm going to try that. 5 divided by 2 is 2.5. 12.5 divided by 5 is 2.5. 31.25 divided by 12.5 is 2.5. 78.125 divided by 31.25 is 2.5. So my successive quotients are all 2.5. So that means that this is exponential. Since it's exponential, I know the equation is y is equal to a times b to the x power. I know that a is my initial value, y when x equals 0, so this is 2. My b is always my successive quotient. Don't want all of that circled. Is my successive quotient, so this is 2.5 to the x power. Let's do number 3. Number 3, again, differences. 5 minus 3 is 2. 7 minus 5 is 2. 9 minus 7 is 2. 11 minus 9 is 2. So this has to be linear. I know it's y equals mx plus b. My m is my first difference, so it's y is equal to 2x. My b is my y when x is 0, so plus 3. And number 4. If I look at this again, all the decimals tell me to try exponential first. It doesn't hurt to try it first. If I'm wrong, I'm wrong. But I'm going to try exponential first. 0.75 divided by 0.5 is 1.5. 1.125 divided by 0.75 is 1.5. 1.6875 divided by 1.125 is 1.5. 2.5313 divided by 1.68, oh, I forgot the point, 0.6875 if I round, I'm still going to get 1.5. So this tells me, since my successive quotients are all the same, that 1.5 is my successive quotient or my common multiplier. That means that this is exponential. So again, y is equal to a times b to the x power. A is y when x is 0, so y is equal to 0.5 times b is my successive quotient or common multiplier, 1.5 to the x power. That's to the x power. Kind of ran out of space there, to the x power. Okay, that's 1 through 4. Let's go ahead and do 5 through 8. Okay, same thing. Try my differences, 0.5, 1.5. Here it's going to be 3.5. Here it's going to be, what is that, 5.5? Nope. Sorry. Okay, let me double check. Maybe I just made a mistake. 0.5 minus 0 is 0.5. 2 minus 0.5 is 1.5. 4.5 minus 2 is 2.5. 8 minus 4.5 is 3.5. Okay. First differences are not the same. What about my second differences? 1.5 minus 0.5 is 1. 2.5 minus 1.5 is 1. 3.5 minus 2.5 is 1. So this is quadratic. Again, y equals a times x squared plus bx plus c. A is half the second difference, so it's half of 1, which is 0.5 or 0.5. C is y when x is 0, so c is 0. To find b, I need to do FUD. My first difference is equal to a plus b. My first difference is 0.5, or 0.5, is equal to a, which is 0.5 plus b. Subtract 0.5 from both sides. I get 0 is equal to b. So my equation is y is equal to 0.5 x squared plus 0x plus 0. So that's my function. That's my equation. I'm going to erase some of this so I have room for my next problem. Number 6, again, do my differences. Negative 1.5 minus a negative 2 is 0.5. Negative 1 minus a negative 1.5 is 0.5. Negative 0.5 minus a negative 1 is 0.5. 0 minus a negative 0.5 is 0.5. So this has to be linear. Y equals mx plus b. My m is my first difference, 0.5. My b is y when x is 0 minus 2. Y equals 0.5x minus 2. If I do my differences here, I get 1.5. I lied. 1.5 minus 0.75 is 0.75. 3 minus 1.5 is 1.5. 6 minus 3 is 3. 12 minus 6 is 6. If I do my second differences, I'm going to get the same thing. 0.75, 1.5, and 3. I get a repetition of my same list. So it's not linear, it's not quadratic. Let's try successive quotients. 1.5 divided by 0.75 is 2. 3 divided by 1.5 is 2. 6 divided by 3 is 2. 12 divided by 6 is 2. That tells me since my successive quotients are all the same, it has to be exponential. Y equals a times b to the x. A is y when x equals 0, 0.75. B is my successive quotient, 2. So it's y is equal to 0.75 times 2 to the x power. Lastly, number 8. Number 8, again, with all the decimals, I'm going to kind of guess that this is exponential. It could be exponential without it. It could be something else. But I'm going to guess that it's exponential. And I'm going to start by checking that first. So we're going to take 10.5. And we're going to divide that by 3. We're going to take 36.75, divide that by 10.5. We're going to take 128.63 and divide that by 36.75. That's 3.5, even though I have to round there. And I'm going to take 450.19 and divide that by 128.63. And again, rounding, that's going to be 3.5. That tells me that my successive quotient is 3.5. So that tells me it's exponential since it has a common successive quotient. So that tells me that y is equal to a times b to the x. A is y when x is 0. So y is equal to 3. A is y when x is 0, so y is 3. My successive quotient is 3.5, or my common multiplier is 3.5. So y is equal to 3 times 3.5 to the x power. All right, so that's 1 through 8. Now we have 9 through 12. So again, I'm going to start with my differences. Excuse me, 22 minus 12 is 10. 12 minus 6 is 6. 6 minus 4 is 2. 4 minus 6 is a negative 2. My second differences. 10 minus 6 is 4. 6 minus 4 is 2. 2 minus a negative 2 is 4. All of these are 4. So that tells me that it's quadratic, since my second differences are the same. Okay, so that's y is equal to ax squared plus bx plus c. Okay, I need to find a, b, and c. A is half my second difference, so half of 4 is 2. C is y when x is 0, so C is 6. To find B, I use FUD. My first difference is equal to A plus B. So that tells me that negative 2 is equal to A, which is 2 plus B. My first difference is negative 2. That's equal to A plus B, so I subtract 2 from both sides. I get negative 4 is equal to B. So my equation is y is equal to A, which is 2x squared, minus 4x plus 6. There's my quadratic. Number 10, my differences are going to be 4.5. 18 minus 4.5, I believe, is 13.5. 18 minus 40.5, or 40.5 minus 18, is going to be, is that 32? Probably 31. Actually 20. 21.5. 22.5. 22.5. And lastly, 72 minus 40.5. Yeah, I'm going to need the calculator for that. So I had done 40.5 minus 18. 22.5. 72 minus 40.5 is 31.5. Okay, my second difference is here. 13.5 minus 4 is 9, 4.5. 22.5 minus 13 is 9. 31.5 minus 22.5 is 9. Get 9 every time, 9 every time, 9 every time. Check it with the calculator if you're not sure. 13.5 minus 4.5 is 9. 22.5 minus 13.5. Okay, let's try that again. 22.5 minus 13.5 is 9. And then 13.5 minus 4.5 is 9. So my second differences are the same. This has to be quadratic. Y equals ax squared plus bx plus c. So I do the same thing. Y equals ax squared plus bx plus c. My a is half the second difference. So a is 1/2 of 9, which is 4.5. My b is, I always do c next. My c is y when x is 0, so that's 0. To find my b, I do FUD. My first difference is equal to a plus b, so that's 4.5. My first difference is equal to a, which is 4.5 plus b. Subtract 4.5 from both sides. 0 is equal to b. So c and b are both 0, so y is equal to a, which is 4.5 x squared plus 0x plus 0. So number 10 is y equals 4.5 x squared. All right, let's try number 11. 0.5 minus 3 is negative 2.5. Negative 2 minus 0.5 is negative 2.5. Negative 4.5 minus a negative 2 is negative 2.5. Negative 7 minus a negative 4.5 is negative 2.5. My first differences are all the same, so this is linear. y equals mx plus b. My m is the first difference, so y is equal to negative 2.5 x plus b. b is y when x is 0, so that's plus 3. There's my equation. Lastly, let's start with number 12. Again, I could start with my differences, but because I have these lovely fractions that go through here, I'm going to try and I'm going to guess to see if exponential is going to work first, because the fractions, the decimals, tend to tell me that exponential goes first. So let's take 2.5 and divide by 1. Let's take 6.25 and divide by 2.5. Let's take 15.625 and divide by divide by 6.25. I forgot a decimal in there, but that would give me 2.5. Take 39.063 and divide by 15.625. Again, I forgot my decimal, 0.625. And again, I get 2.5. Even though there's a little mistake right here, my successive quotients are all 2.5 all the way down. So this tells me it's exponential. So that's y is equal to a times b to the x power. A is y when x is 0, so y is equal to 1 times b is my successive quotient, 2.5 to the x power. So y is equal to 1 times 2.5 to the x power. Since it's times 1, I can leave the 1 off, so y is 2.5 to the x power. That's 1 through 12. All right. Exponential functions. Use the function f of x equals 0.5 times 3.25 to the x for numbers 1 through 6. Graph the function. I'm going to pull up the calculator. I'm going to hit clear. And I'm going to go to y equals, and I'm going to plug in. I'm going to turn off my stat plot. Try that again. Go up to plot, hit enter to turn it off. I'm going to plug in y equals 0.5 times 3.25 to the x power. Now, if I look at the graph that I'm given, I can easily mark it off 0 to 10, 0 to 10, because these are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is a 10 by 10 grid. So I'm going to make my graph match that, since that's what I'm graphing. So I'm going to go to my window. I'm going to make my x minimum 0, my y x minimum 10, count by 1 because my graph is counting by 1. My y minimum is 0. My y max is 10, count by 1s. And I'm going to graph. That's what my graph looks like. Now, let's actually plot points. So I'm going to hit second graph to go to the table menu. And I'm going to graph the points 0.5. So x is 0, y is 1/2. 1.625. So that's a little more than 1.5. 2 is 5.28. 2 is 1, 2, 3, 4, 5.28 will be right there. And so my graph does something like that. There's the graph that it asked me to graph. So it's 0.5 times 3.25 to the x power. So again, it was 0.5 times 3.25 to the x power. All right, fill in the table with 5 values of the function. Well, again, here's my table. I can just use these here. 0 is 0.5, 1 is 1.6625, 2 is 5.2813. 3 is 17.16, and 4 is 55.78. Going to 2 decimal places should be plenty. What is the y-intercept of the graph? Well, y-intercept is where I cross, where x is 0. So that's the coordinate 0.5 or just 0.5. What is the common multiplier? Well, here's my common multiplier, 3.25. This was my y-intercept, by the way. Is f of x a continuous or discrete function? It is continuous. For what we do, the only times it's discrete is if I have a scenario where I'm picking people or I'm cutting paper, or I can only have whole objects. For the most part, otherwise it's going to be continuous. If f of x equals 0.5 times 3.25 to the x, is it a vertical stretch or a vertical compression? It's a vertical compression. Why is it a vertical compression? Because my A, my 0.5, is between 0 and 1, so it's compression. If it's greater than 1, it's a vertical stretch. Use the following table about moose population to answer the following questions. 1993 is the first year, so this is year 0, 1, 2, 3, 4, 5, and 6. My population is 27, 31, 36, 42, 48, 56, and 65. I want my successive quotient, so I'm going to bring up my handy-dandy calculator. I'm going to come over here, and I'm going to go to a clear screen, and I'm going to take 31 and divide by 27. I get 1 point, if I round to 2 decimal places, 1.15. Okay, so now let's take 36 and divide by 31. And I get 1.16. And if I take, by the way, both of these I started a little high. You should always leave the first one blank. Okay? 42 divided by 36. 1.17. And then 48 divided by 42. 1.14. And then 56 divided by 48. 1.17. And then 65 divided by 56. 1.16. Running out of time. All of these are close. This is not something that's linear. This goes up by 4, and then this goes up by 5, and then this goes up by 4, and this goes up by 6. So this is going to be exponential, but I need a number to use. And so what I'm going to do is I'm going to take these successive quotients, and I'm going to add them and divide by 6, because there's 6 of them. 1.15 plus 1.16 plus 1.17 plus 1.14 plus 1.17 plus 1.16. I'm going to divide that by 6, and I get 1.16. And so that's what I'm going to use as my successive quotient, 1.16. So determine the growth rate. 1.16, that tells me my growth rate is this 6.16 or 16%. Find a function that models the growth. Well, that's y is equal to a times b to the x power. A is x, excuse me, y when x is 0. So that's going to be y is equal to 27 times my successive quotient 1.16 to the x power. Use your function to predict the population in the year 2002. So 1993 and 2002. So I do 2002 minus 1993, and I get 9 years. So I need to plug in 9 for x. So this is 27 times 1.16 to the 9th power. And so the population in 2002 is going to be a little about 102, between 102 and 103. Use your function to find the moose population when it's 500. Excuse me. So I want to know when my population is 500. So I'm going to go to my calculator. I'm going to go y equals. I'm going to plug in what I know. I want my y to be 27 times 1.16 to the x power. And I could guess my x's. I'm going to make my y's go from, I need to get up to 500. So I'm going to go from 0 to 600. My x's, I'm going to guess something like 50. I want my y2 to be 500. And I'm going to graph these. I want to find that intersection. So I do second trace. Number 5 is intersection 1, 2, 3. 19.66. So it's going to be in about 20 years. Because in 19 years, it's not there yet. Since I started in 1993, 20 years would be 2013. That's everything.